Could a single, insignificant screw bring the colossal automotive industry to its knees? What if the most complex machine of the modern age, a symphony of over 30,000 individual parts, could be silenced not by a catastrophic engine failure or a global economic crash, but by the absence of one of its humblest components? How does this seemingly simple object reveal the profound fragility of a system we perceive as unbreakable? And what does it tell us about the hidden power dynamics that govern global manufacturing? Is the story of a screw merely a manufacturing concern? Or is it a stark metaphor for the intricate, often invisible dependencies that define our interconnected world? The modern automobile is a testament to precision engineering, a marvel where every component, regardless of its size or perceived simplicity, holds a critical function. A single defective screw, a misaligned bolt, or an improperly forged fastener can initiate a cascade of failures with devastating consequences. Consider the immense forces at play within a running engine or the structural integrity required to protect passengers in a collision. In these scenarios, the failure of a component costing mere cents can lead to catastrophic malfunctions, triggering mass recalls that cost manufacturers billions of dollars and irreparably damage their reputation. This illustrates a fundamental principle of complex systems. The system is only as strong as its weakest link. The absence or failure of a seemingly trivial part like a specialized screw can halt an entire assembly line. Production schedules, meticulously planned months or even years in advance, can be thrown into disarray. The financial implications are staggering as idle factories hemorrhage money. Delivery deadlines are missed, creating a domino effect that ripples through dealerships, service centers, and ultimately to the consumer. This isn't a theoretical exercise. It's a daily operational reality for plant managers and supply chain logisticians. A shortage of a specific fastener, even for a few hours, can mean the difference between a profitable quarter and a significant loss. This vulnerability underscores the immense pressure on manufacturers to maintain flawless supply chain integrity, where the procurement of a single screw is treated with the same seriousness as the acquisition of a complex transmission system. The intricate dance of just-in-time manufacturing, designed to minimize warehousing costs and maximize efficiency, becomes a high-stakes gamble. When the system works, it's a model of industrial optimization. But when a single low-value part fails to arrive, the entire synchronized operation grinds to a sudden, costly halt, exposing the inherent risk in such a lean operational model. This extreme sensitivity to minor disruptions is magnified by the industry's profound reliance on sprawling, globalized supply chains. The journey of a single car from raw material to showroom floor is a planetary ballet of logistics. Iron or mined in Australia might be forged into steel in South Korea, which is then shipped to Mexico to be stamped into a body panel, which is then sent to a final assembly plant in the United States. This complex network, while economically efficient, is a breeding ground for vulnerabilities. A labor strike at a port in one hemisphere, a natural disaster in another, or new trade tariffs imposed by a government can sever a critical artery in this global system. When a nation like Vietnam, a rising player in manufacturing, struggles to produce even basic components like screws to the exacting standards of the automotive industry, it lays bare the precarious nature of this interdependence. The inability to source such parts domestically forces a deeper reliance on a handful of specialized international suppliers. This concentration of supply creates choke points. If a single factory in Germany or Japan, renowned for its specialized metallurgical expertise, faces a disruption, it can impact a dozen different car brands across the globe simultaneously. The increased reliance on imports introduces a host of new variables and risks. Shipping costs fluctuate, geopolitical tensions can weaponize trade routes, and lead times for critical components can stretch from weeks to months. For an industry built on the principles of lean manufacturing, these delays are not just inconvenient. They are an existential threat to profitability and market competitiveness. The cost of a screw is no longer just its manufacturing price. It now includes the price of shipping, the risk of tariffs, the insurance against a dozen potential disruptions along its thousands of mile journey. The challenge transcends simple logistics and delves into the realms of advanced materials science and metallurgical technology. While any nation with basic industrial capacity can produce a generic screw, the automotive industry demands far more. The fasteners used in a modern vehicle are highly engineered components. designed to withstand specific levels of stress, vibration, and temperature extremes. A screw for an engine mount is fundamentally different from one used to secure an interior trim panel. The former requires specialized alloys, heat treatments, and coating processes to ensure it doesn't shear under load or corrode over time. This is where a significant technological gap emerges, developing the domestic capacity to produce high-specification components requires a massive investment in research and development, advanced foundries, and a highly skilled workforce trained in materials science. It is not merely a matter of replicating a design. It is about mastering the complex, often proprietary processes that create the material's essential properties. The lack of this deep technological base becomes a major impediment to the comprehensive development of a nation's automotive industry. Without the ability to produce these critical, high-value parts, a country's industry remains relegated to lower-level assembly, perpetually dependent on foreign technology and expertise. This creates a ceiling on industrial advancement, preventing the transition from a mere assembly hub to a true automotive powerhouse capable of independent design, engineering, and manufacturing. The screw, in this context, becomes a symbol of this technological dependency, a small but potent indicator of a much larger industrial and economic challenge. The ability to manufacture the entire car, from the engine block down to the last specialized bolt, is the true hallmark of a self-sufficient and competitive automotive sector. This technological barrier is often reinforced by deliberate competitive strategy. The cutthroat world of the automotive industry, intellectual property is a fortress. Major manufacturers often engineer their vehicles around proprietary components, including fasteners with unique shapes, sizes, or thread patterns. This is not just a matter of design preference. It is a calculated business decision. By using specially designed screws that cannot be sourced from a generic supplier, automakers lock in their control over the aftermarket and repair industries. This strategy, known as vendor lock-in, ensures that repairs and part replacements must be done using official, original equipment manufacturer (OEM) components, which are sold at a significant premium. It also acts as a powerful barrier to entry for competitors. A rival company cannot simply reverse engineer a vehicle if it cannot source or replicate the hundreds of unique fasteners required for its assembly. This strategic use of simple components transforms the screw from a mere piece of hardware into a key that unlocks a lucrative, closed ecosystem of service and parts. It complicates the global supply chain even further, as the blueprints for these proprietary parts are jealously guarded secrets. This forces a tiered system of suppliers, where only a select few are granted the licenses and technical specifications to produce these components. Further concentrating power and increasing the risk of disruption, the design of a screw head becomes less about engineering efficiency and more about market control, a subtle but powerful tool in the global battle for automotive supremacy. What does it mean for a global industry to be so utterly dependent on its smallest, most overlooked parts? If a single screw can hold so much power, what other invisible points of failure exist within our complex global systems? As technology makes our machines more intricate and our supply chains more interconnected, are we building systems of greater strength or greater fragility? And ultimately, who truly holds the power? The one who designs the engine, or the one who controls the screw?